Hello, everyone. Thanks for coming to this talk. I'm happy to be here, closing the conference. It's almost time to say goodbye. I know, but we still have some time to talk about Protobuf on Android using gRPC. So welcome to this talk. As I said, we're going to talk about protocol buffers on Android using gRPC. And before I start with the topic, I always would like to mention what to expect from this talk. So remember, this is an introductory session, which means that I'm gonna give an overview about what is Protobuf and gRPC, and also why and when you should use them, right? In the same way, what don't expect is that you're going to be an expert after this talk, right? Also, don't expect that Protobuf will solve all your problems. We haven't managed to come with a technology that solves all our problems. This one solves one of many, but unfortunately won't fix all your problems, right? And also don't expect stickers and free merchandise. I didn't bring any with me, so we'll leave for the next time. All right. So let me then do a little short introduction about myself. I'm Diego Alvis. I'm engineering manager at Delivery Hero. And I love spicy food. Any fan of spicy food? Spicy food? Cool. And something interesting about me is that I was a bus driver before becoming a developer. Maybe it's not that relevant, but yeah, I just wanted to share some fun fact about me in this today. Right. Cool. So after this short introduction, let's then get started with the talk. Today we're going to talk about what is Protobuf, where can we use it, also what is gRPC, because I know it's very common to mistake or to mismatch these two terminals. Also the benefits of Protobuf and gRPC, and a particular example, a practical example about the implementation on Android, some benchmarking, and finally some learnings that I have gained during the journey of using protocol buffers and gRPC. Right? Cool. So before to start talking about Protobuf, let me first start explaining or maybe give you a little bit of context. Where are we going to be located during this talk, right? So this is more or less what we usually have on a daily basis, in a very high level architecture of a system, right? When we have on the left side the client, and we have a server, right? So basically client with the traditional separation of layers with presentation, domain, and data. And we have on the other side the server running application in the backend. And when we are going to be located today is around the API part, right? The communication between server and the client, right? And I mention this because it's very common to see a lot of talks, mostly about the client, like about Compose, about view models, Gradle, Flow, and many things that we can use on the client side, but I've seen very little talks about something like this, right? The API communication or other things that we as a mobile engineers are also involved and are impacted by that, but somehow we don't give enough relevance, in my opinion, right? And I think one of the reasons of that is that as a mobile engineers, we tend to delegate this to the backend teams, but we are as responsible as the other backend team is for maintaining have a good API, let's say, communication system, right? So I'm going to give you my personal reasons why it's relevant that you come to this talk and we talk about this part of the system, right? So the first one is that we are mobile. What I mean by this is that we need to also play a more active role in defining things that are directly or indirectly affected by us, right? For example, the API communication in this case, right? Also, it's important to pay attention to the API because you can't build an amazing product if you don't have an API layer that is not amazing, right? Even if you put animations, UI, colors, fonts, but if your API sucks, then you're going to have a very bad experience, user experience, which means that you're going to have a bad product at the end of the day. And finally, they will help you to leverage your knowledge about software in general. When I started working with this, I realized how little I knew about how the backend works. And gaining this knowledge helped me to understand software in a better, like a bigger picture. And with that knowledge and being more aware of the system as a whole, you can make better decisions when you're building software, right? So those are my reasons why we should, basically why you should come to this talk and why should I give, have more of these talks in our conferences and in our daily basis, right? Cool. So yeah, after that, now let's get started with the topic. First, what is Protobuf? So basically, protocol buffers, or Protobuf, is a language-agnostic data serialization format developed by Google. It allows you to define structured data schemas in a sample language. And another example of, let's say, data serialization formats are XML and JSON, which we widely use every day, right? However, Protobuf are more compact and efficient compared with these two. And I will explain why in a bit, right? So basically, Protobuf is a way to structure the data that we send across our system. So let's see then how we can, or what is the definition of the data of this structure that I'm talking about here, right? So first, let's take a look at the traditional ones. We have here JSON on the left, XML on the right. They both are quite similar. They both are a key value format structure. So we have the ID, which is an integer, and the ID is the key. We have name, and we have email, and the other side we have pretty much the same, right? Now, Protobuf, this is how it looks. I don't know if it's visible, though. In Protobuf, at first glance, it looks similar. However, there is a small but important difference, right? In Protobuf, we don't have keys. What we have is, or what Protobuf uses, is the position. Right? So Protobuf uses the position to identify the value inside of the message. Right? So when we define a Protobuf message, we have to put the type, the name of the field, and the position, let's say in the payload of the information. There is a constraint, which is that Protobuf uses up to 2 bytes for the position, or to identify the fields. Right? It's going to use 1 byte if the position is between 1 and 15, and 2 bytes if the position is between 16 and 2047. Right? So there is a recommendation here that the most used values of your message, you should put it in the first 15. Right? If you have optional values that might go or might not go, we're better to put it in the other part. Right? There are some remaining bytes that are used for control and security, so they're not count, they don't count. This is a practical example of how the data looks like it. So I'm putting here the, or we're seeing here the data in plain text. In this case, we're using XML. And we're sending a basic piece of information, which is person entity with name and email. Right? So in JSON, in XML, when we send the information using plain text, this payload will have around 69 bytes, right? But in the other side, with Protobuf, as we're getting rid of the IDs, then we have 28 bytes for exactly the same information as the other one, right? So we have almost half of the data that is being transmitted. All right, now let's make a numerical example here, right? So I was working on an application, and I took an average HTTP call that we make very often, and it was around 3 kilobytes of information, right? And that payload was in JSON format, so I made the exercise to translate it to Protobuf format, and it turned out being 1.3 kilobytes of information in Protobuf. So that means that I'm saving 1.6 kilobytes in this request, right? So if you're making this call 100 times per day, then you're going to be saving, in 1 month, 4.8 megabytes. And then, this doesn't sound much, if you think about it, right? Like, all these things only to have this little data set, right? But if you put in perspective that you can have more users, let's say this one was only 1 user, but if you have 5,000 users, then you're going to save 24 gigabytes in 1 month. And then we can continue, right? Is this exercise for only 1 call? But I'm pretty sure your applications, you are using more than 1 call and probably more than 3 kilobytes of information. Right? However, saving the data or saving some data is very appreciated by the user. But the main benefit of this, or a consequence of this, is that Protobuf can be up to 7 times faster than the traditional formats, right? Like JSON and XML. And that's main benefit of using Protobuf, right? And of course, saving some data on the way. All right. So now let's talk about gRPC. Now that we know what is Protobuf, let's talk about what is gRPC. Basically, gRPC is a framework for remote procedure calls developed by Google. gRPC, by default, uses Protobuf, and other examples of remote procedure calls are GraphQL and REST. Right? So gRPC is the framework, and Protobuf is the format of the data. That's how it works. Like, you can make the comparison with REST. Like, the REST is the framework, and JSON is the format of the data. That's it. That's all what it is, and that's the difference between gRPC and Protobuf. And the most important thing is that gRPC uses by default Protobuf because it was designed with that in mind, right? It was designed to be to support Protobuf as the first option for the data. This is more or less how it looks, how a say system that is using gRPC looks like. So you're going to have a server which is running a gRPC server, and you also have clients that are also running gRPC, and you're going to have proto requests and proto responses in the communication between them. Cool. In gRPC, we have 4 ways to communicate or to establish communication. Right? The first one is unary. So unary is when you send one single message, and then you get one single message. Server streaming is when the client sends one single message, but the server responds with a stream of events or a stream of messages. And the other way around, you have client streaming, which is the client sending a stream of messages. And you have bidirectional streaming, which is both sending and stream of messages, right? And if you are familiarized with flow, this is pretty much the same. Right? This is flow, but for communication between client and server. For this particular talk, we're going to focus on the unary one. because the servers, the streaming ones, are, let's say, are more focused when you require a more complex scenario, and also when you require high-performance APIs. Right? It's more like a for real-time or event-based applications or functionalities. Right. So once we clarify what's gRPC, once we know what is Protobuf, let's see how we can define our contract or a schema for this communication. Right. So you're going to have to, or for this particular example, we're going to have to define a protofile, which is going to be our schema, and I'm going to define the protofile or the schema for a booking system. Right. So what I have here is that I'm going to start with the syntax definition. I'm going to use the version 3 of Protobuf. I think it's the latest one, last time I checked. Then you have the package, which is identifier for the service. And here I have defined the passenger. Right? So the passenger will have an ID in the first position, name in the second, and email in the third. And I'm going to have a request. And finally, the service will define all the calls that your schema will have in the communication. I'm just going to have one, which is get passenger. I'm going to send the request, and they will return the passenger object. So let's review a little bit more of the syntaxes of the protofile. So as I mentioned, you have to define always the type, then the name, and the position. Right? But if you have an optional value, you can put optional here. And let's say I'm going to use passport as an optional in the position 4. Or I can say, oh, let's put it in the position 45, because it's probably not going to be common. I'm going to save the 15 first position for most common cases. Right? So if you want to send a collection or a list, then you will use repeated string, and let's say addresses for a collection of addresses. Right? We usually have more than one address, so it makes sense to have a collection for the address. Right? All right. Protobuf force you to always put a request here, even if it's empty. You need to put something there. But like in this example, I can put something, or I can just leave it empty. But I can, let's say, use maybe an integer and use the ID for this. Right? But as I said, it's something completely optional. And this one is a unary call. But if you want to have a client streaming or serving streaming or bidirectional, then you will add, let me copy this one here. And then you will add the reserved word stream. So this one will be client streaming, because it's the client who is sending the stream, right? This is let's say the body of the request, the one that is in the first place. And if you're gonna have a server streaming, then you will define here the stream. And you're gonna have bidirectional, then you put stream in both sides. Let's do it. So bidirectional would be stream here and stream here. Right? That's pretty much, or very like in a nutshell, how the protofile looks like. You can have more things. You can even run logic here, but I'm not gonna deep down in these details for now. All right. So once we have defined our schema, as you see, like we have the entities, in this case only two, passenger and my request, and we have a couple of methods that we're going to use for the communication, right? So once we have the schema, we're going to use, or gRPC will use this schema to auto-generate code for you. Right? So, and this is very key, very important, and one of the biggest benefits of using gRPC. Once you define the proto file, you're going to have a copy in the client side, and you're going to have a copy in the server side. Ideally, it should be the same copy. And using a proto compiler provided by gRPC, you will get auto-generated code, auto-generated classes, logic, and everything ready to be used in the communication. So you don't have to worry about writing data classes, the contract, and anything like that, right? So that's the main benefit of using gRPC. And another good thing about this is that it prevents and is less prone to error. It prevents the error. Because if we use the same compiler and if we use the same schema, then the types of the fields are going to be the same, right? And a particular example that happened to me was that used to have a field called quantity, and on the client side was an integer, but in the server was a big decimal or double, and after many months, they start sending decimal numbers, and it completely breaks the application in pieces. So we need to hotfix that, and it was very bad, right? But with this, you will prevent that because as it's been delegated to the compiler, you can be sure that you don't have any type that is wrong used. Right? You can also use it manually. You can build your classes manually, but then you're losing main benefit of using gRPC, so not really much sense on doing that. All right, then to summarize the benefits of gRPC and Protobuf, we have the efficiency realization because the messages are smaller compared with JSON and XML. It's language agnostic. gRPC supports multiple programming languages. And I'm talking here about the compiler. It will generate code in different languages. Also, versioning and backwards compatibility is easy to evolve because we have the schema, so it's easy to add more values there without having to generate a new endpoint with the B1, B2, and other things that we usually do with RESTful, for example. And main benefit, which is auto-generate code using the schema as the base file. Right? These are the languages that are supported by the compiler. If you don't find your language there, then you can do it manually, as I said. But yeah, I strongly recommend to not do it. So you make the most out of the compiler. All right. Then we talk about Protobuf and gRPC. Let's now see how we can integrate this in an Android application, right? So for this example, and since it's summer, I was thinking to build, or I thought to build an application that is an ice cream application because it's summer, and in summer I usually eat ice cream. So yeah. First step to implement or integrate Protobuf and gRPC on Android. So first you have to define the schema, right? So the first thing that I'm going to do is create ice cream.proto file, and we'll define these two messages or these two entities. One is the cone, which has the ID, image URL, and available, just to see if the cone is available or not. And then we have the flavor, pretty much similar. The only thing is it has a description, which is optional, and the price. In the same way, I will define the services. So, okay, again, the rest of the messages, that is the request, cones reply, and flavors reply. And I'm going to have two methods get cones to get all the cones, and get flavors to get all the flavors. Cool. Once we have defined the proto file, then let's add the dependencies to our project. Right? So to add a project, I just listed these ones. However, there are other more if you wanted to have more like extension functions and fancy stuff. But these are, let's say, the most basic ones that you need to run gRPC on your project. Remember that we are going to use the compiler, which will generate the code for you. And the compiler will generate some classes in Java, some classes in Kotlin, thanks to interoperability between those. So they just decided to just keep using the Java one and don't reinvent the wheel. Cool. After we have added the dependencies, we're going to set up the Protobuf compiler, the compiler that I was mentioning about in the plugin. This is basically a basic setup. The difference here is that if you're going to set up gRPC for Java, then you don't need the Kotlin ones, but that's it. The rest is like the same. And finally, no, sorry, that's enough. We are in the hub. After this, we're gonna run our project, the Gradle task that will generate the code. And after that, you're gonna see something like this, right? So you're gonna have ice cream gRPC, cone reply, and all these classes that, as I explained before, you don't have to do manually. So they are all for you, ready to be used. Okay. All right. So now we have all the resources that we need. Then it's time for us to code. So in order to start using or establish the communication, we need to first, or we need basically two things. First, we need to create or define the channel. And a channel is basically the one that is providing the connection to a gRPC server, specifying the host and the port. A channel can be reused for make multiple gRPC calls, and it's been multiplexed under the hood by the gRPC libraries, so you don't have to worry about that. And you can create clients using one single channel. Actually, it's the recommendation from gRPC that you use only one channel. Right? This is how you create the channel. It's one line. It's a builder, so you can add more things, but this is basically the creation of the channel. Right? And then you have the client stop. Right? The client stop basically is the entry point to make the calls, right? In gRPC. It's again auto-generated, and this is amazing. It's coroutine based. Right? So we already are using lightweight libraries available in Kotlin. Again, one line, but you need to have the channel first, right? Because you need to specify in which channel this client is going to be performing the calls. Perfect. Then, once we have the channel and the stop, we can define the methods. So for this case, I will create the get cones. This request that you see here is a builder provided by the gRPC plugin. Is already auto-generated, and the same goes for this. Right? This is already generated this method. Right? So I'm just gonna pass this request, and I will gonna get a list of cones. The same happens for the flavors. And one thing to keep in mind always is that you need to shut down your channel if you're not longer using it. All right, that's it. I will try to show here a live demo, but if not, I have a video prepared. As you can see here, there are these classes you have you have the cones, you have the flavors. As you can see, it's Java code, but you also have some classes generated in Kotlin. Where are the, yeah, like these ones, right? But you can take a look at them later. They are basically just auto-generated classes. Here are our proto file, and I built this basic application. I'm running a server as well locally, and I'm loading here the flavors. I'm loading here the cones from this local server, which I should have over here. And yeah, basically this is my ice cream application. Right? Very simple, but just to demonstrate the the code. Cool. Then to summarize, I said this is the most important part of the or the most relevant part for this talk of the application, when we had defined the service using all the auto-generated code by gRPC. And yeah, I just have a couple of things more, like some try catch. Something that I would like to mention here is that it's important that you define the dispatcher as an executor. So gRPC knows in which thread you're going to make your calls. Right. Then that's it about the application. I created a more complex example just to have some metrics. It was a big payload, actually. And I was making some benchmarks, right? So I found out that REST performs worse than gRPC in high-specs devices, right? So as you can see, it was a very big payload. I have sometimes almost 3 seconds. But overall, gRPC was performing way better than REST in this case, right? Also, the battery was very decent, like it wasn't any peak, and the memory was also like okay, so all good in this case, right? However, I also ran this same test, but in a low specs device, and I found out here that gRPC was not performing well at all. Right? I had to go very, very low specs, by the way, right? And also the payload was quite big, right? And as I mentioned at the beginning, it's not going to solve all your problems. It cannot cover all the cases. So apparently, gRPC doesn't perform well in low resources environment. Right? Also, the battery and the CPU and the memory were, as you can see, not doing well as well. So yeah, things that you find when doing these experiments, right? Another benchmark that I found very interesting is the trend. gRPC was released 2016, and in the last 5 years, there isn't any like indicator that is going to change or is going to replace RESTful, right? So this is still the REST is still the dominant one, and we have also GraphQL, and as you can see, gRPC is not as popular as both of them. So this something that is worth to mention. Was extremely hard to find documentation, by the way, especially for mobile, because it's very applicable for server to server, but server to mobile, it's a little bit more rare in the things that I found. All right. Summary then. Some benefits of gRPC and Protobuf is that the code generation simplifies the integration. And I'm going to mention this a couple of times more. It really speeds up the development if you have everything ready and to be worked on. Right? The parsing is efficient, it's less prone to error. You don't have to worry about making mistakes because you maybe miss a type of a value. It's strongly typed, which is more or less what I just said. Prevents errors and enables high performance and networking. Right. There's also some cons, right, as always. So the ones that I have found is that the limited community support compared to REST and GraphQL. Right? So we're struggling find references in examples. Hopefully it will change. Protobuf requires a little bit of knowledge. Otherwise, you're going to be a little bit lost to change this mindset of the position thing. Hence, has a steeper learning curve. Right. Cool. So during my journey using gRPC, which has been like 1 year in the company, I have a couple of advices and learnings that I would like to share. First is that gRPC will make your app faster and less prone to error. Already mentioned it. The setup might be time consuming, so please allocate enough time and capacity to do the setup, because it's not straightforward as I thought. This one is a bit controversial, I would say, but in my personal opinion, you don't need to migrate things that are in REST, and especially in GraphQL, to use gRPC. I really recommend that you consider it for new developments, but if you have something working, I mean, unless there are some like hard constraint, I really don't recommend, because it doesn't cover all the cases. At least for us, that was the case. And the interceptors are something that I didn't want to cover this stuff because it was a huge topic. But they are not as simple again. We struggle a lot having interceptors, so don't leave them for the end. Like, don't say, like, okay, let's do everything, and then interceptors to authorization things and so on. And yeah, I think it needs more support from the mobile community. There are a lot of documentation in server-to-server communication, but very little with mobile community, so I hope this will change, as I said, but yeah, for now, that is the situation. All right, everyone, that's it. Thank you for listening.